Now let's discuss uh, the base representation. Okay. Now let's let b be a positive integer greater than 1. So b is a positive integer and b is greater than 1. And at the same time, let's assume that n is a positive integer and we want to show the base b representation. Then in a general form, it will be written as n is equal to a of k times b of k plus ak minus 1 times b raised power k minus 1 plus so on to a1 b raised power 1 plus a0 b raised power 0. So b raised power 0 is equal to 1. Anything raised power 0 is 1. So we will represent it only with a0. Now the other thing that we need to take into consideration is k is a non-negative integer. K is non-negative and at the same time k is an integer. K belongs to integers and a of k is not equal to 0. And in general, if we have a j which represents any of these in a general form, then we say that j ranges from 0, 1, all the way up to k. Now, when we do this base conversion or base representation, we have a string of numbers given to us. We have a string of numbers given to us, which might be of the form of this. Since we are following this kind of representation where we have those numbers as a of k minus 1, the string will be of the form of a k minus 1, a k minus 2, so on to a1 and a0. And what all of this means will be quite clear with some of the examples, and we have them in the form of if they are already in base b representation, then usually for the decimal representation, we omit this. So if some number is given to us in a decimal form, we don't write 10 here. So it's quite clearly evident that without showing this 10, that this is a decimal form. This is in the decimal form. Now, what all of this means, what all of this representation means, it will be quite clear with some of the examples. Now let's take an example where we have octal expansion, and we want to convert it into a decimal expansion. So what will be the decimal representation of, what will be the, what is the decimal? Let me make it a little bit more bold. What's the decimal representation of so in the previous example we had these uh, symbols that had different meanings to them, uh, and we had a of k minus 1, a of k minus 2, so on to a of 1, a of 0, and then we had b. So similarly, if we are given this string of numbers and there is 8, so 8 is the base, and here 6 represents a of 0, 1 similarly represents a of 1, and this 0 will be a of 2, and 7 will be a of 3. Now we have them in the octal representation. That's what 8 means here. So 7, 0, 1, 6, 8. This is in the octal representation, and we have to convert them into a decimal representation. Now, as I told you previously, that in order to convert it from one form of expansion into another form of expansion, we also need to take into consideration this base b. So we also need to take into consideration the power of it. In the A terms, we did not have the power associated with it, but in the B terms, we have a power. So this is this has a power 0 associated with this. This is a power 1 associated with this. This has a power 2 associated with this, and this has a power of 3 associated with this. Now, if we have to convert it into a decimal form, let's expand it. So this is 6 times 8 to the power of 0, since the value of b over here is 8. That's what was meant here in this representation. B was the general representation, a general symbol for any kind of representation. So since we know in octal b is equal to 8, so this will be 7016 can be rewritten while expanding it as this. So this will be we are starting from the least significant digit. So this will be, since this has 0 associated with it, so a 0 power of 0 associated with this, so this will become 6 times a raised power 0 plus similarly we have 1 associated with this. This will be 1 times 8 to the with the power of 1 plus 0 times 8 with the power of 2 plus 7 times 8 to the power of 3. So if you calculate these values, this will, what we'll get is 3598. So this is the decimal representation or decimal expansion of 7016. Now the other thing worth noting here is just like in the decimal representation, we have numbers ranging from 0, 1, all the way till 9. In octal representation, we have what we have is numbers ranging from 0 to 7 only. So let's discuss another example, so it will become more clear with that. Let's say we have 111 and it's in its octal representation, and we need to find its decimal representation or decimal expansion. So following the same kind of methodology, what we get is 1 times 8 raised power 0, since this is 0, 1, and 2, plus 1 times 8 raised power 1 plus 1 times 8 with the power of 2. So this will be equal to 1 times 1, which is 1. This will be 1 times 8 plus 8 plus 1 times 8 square, which is equal to 1 times 64. So if you add them up, this will be equal to 73. So that's how we converted a number from its octal representation to its decimal representation. So 73 is its decimal representation.